Here we have a storage container without a lid and whose volume is given as 10 meter cube, and the length of the base is given as twice the width. So I have written as 2 times of width, and we're also given that the cost of the material for base as well as the sides. For the base, it is charged at $5 per square meter, and for the sides, that is the front and rear and left and right, it is charged at $3 per square meter. So this is the situation that we have to consider for the storage container, and we have to answer these three questions. First, we have to answer the cost function. We have to write down a function for the cost in terms of variable w, and then we have to find its derivative, that is c prime of w, and finally we have to find the cost in dollars for the least expensive container. So first, using the given information, let's write the variables length and height, everything in terms of width. So I'm going to use this information. Volume of the storage container is V equal to 10 meter cube, which is 10 without the units. So volume of the storage container, which is basically a rectangular storage container, this is equivalent to length times width times height, and this is given as 10. And we also know that a length is twice the width. So we can write down this relation between length and width as 2w. I'm going to substitute this into this equation and solve for h. So if I substitute L equal to 2w, I get 2w times w times h. This is equal to 10. Now let me solve for h from this equation. So this is equal to 2w square h equal 10. Now I divide both sides by 2w square. So I get h equal to 10 by 2w square, and this is equal to 5 by w square. So let me represent it here. Basically h is 5 by w square, and we also know that length is 2w. So these are the two values or for length as well as height, which we have represented in terms of width. We will now use this information, that is length equal to 2w as well as height equal to 5 by w squared, to construct the cost function. Basically, a cost function is written as cost equal to area of the material, area times the rate. Because we have different rates for base as well as for sides, we will calculate for base. First, let's determine the cost for constructing the base of the container. Cost of base equal to area of the base times rate. Rate here is $5 per square meter. So let me simply put 5 here. Now, looking at the figure, we know that the area of the box is, that is the area of the base of the box is length times width. So let me put it here. So this is LW times 5, which is 5 LW. Now we will have to convert everything into W. So we just have to replace L as 2W, which we will do now. This is 5 times of 2W times of W. So this comes out to be 10W square. So this is the cost of constructing the base. Now we'll find the cost of constructing the sides. The cost of constructing the sites is charged, or it is given at a rate of $3 per square meter. So let's determine what are the sides. We have left as well as right. We have front as well as rear. So as far as the left and right sides are considered, WH is the area. So for sides, for left it is WH, as well as for right also the area is WH. So these two we have to multiply by the rate, which is charged at 3. And similarly, this you can say it as a left as well as right sides, and we have front as well as back. The area of this is, it is length times height. So it's basically 2 times of length times height. So this will be LH, plus LH times the rate. So let's simplify these two. This is WH plus WH is 2WH times of 3, which is 6WH. Now I can replace H as 10 by, I'm sorry, it is 5 by W square. You can see it over here. So when I do that, I'll be getting 5 by W square. When you simplify, this is 6, 5 is 30 over W. And similarly for the cost for constructing the front and back sides is, this is LH plus LH is 2LH, and 2LH times 3 is 6LH. And we will replace both length and height in terms of W. So this will be, we know that length is twice the width, so I replace 2W for L, and H is 5 by W square. So when we simplify this, this is 5, 2 is 10. 10 times 6 is 60 by W, and W square will get cancelled. We will get only W. So these are the costs for constructing the base as well as the sides. For base, it is 10W square, and for sides, we have 30 by W as well as 60 by W. So we have to add all these three quantities. So therefore, the final cost function, cost, which I can represent in terms of C of W, equal to cost of constructing the base is 10W square plus cost of constructing the left and right sides is 30 by W, and for front and back it is 60 by W. So these two are like terms. We can add them together and write down as a single term. So this will be 10W square plus 90 by W. W is a common denominator. So this basically represents the cost function. This is the required cost function. And this means we have just answered the part 1 question. So we have answered this. And in the second part, we have to find the derivative of the cost function. So let's do that now. We'll come back to our cost function. So we have to differentiate with respect to W. So which I'm going to do now. It is C prime of W is equal to, it is 10 times of differentiation of W square is 2W when you apply the power rule. And similarly, this can be considered as 90 times of, I can write down the 90 by W as 90 times of 1 by W, and then I have to differentiate only the 1 by W. So this, if you convert to power and then apply the power rule, it will come out as negative 1 by W square. So I can put here as minus 1 by W square. So let's simplify this. Therefore, C prime of W, which is the derivative of the cost function, is 20W minus 90 by W square. So this is the derivative of the cost function. And this means we have just answered the part 2 of this question. We now have to do the part 3, which is we have to find the cost in dollars of the material for the least expensive storage container. So this is basically we have to apply the calculus to find the minimum value of the cost function. The minimum value usually occurs at C prime of W equal to 0. C prime of W equal to 0. We have to check if at what value of W the cost is minimum. So for that we need the C prime of W. We have it here. So we have to set this equal to 0. So when I do that, this gives 0 equal to 20W minus of 90 by W square. Let's try to solve for W from this one. So this is equal to 20 by W square equal to 20W, and this can be written as 90 divided by 20 is equal to W cube. That is, when you multiply both sides by W squared and then divide by 20, you get this relation. I can cancel this zeros and zeros. So it's basically 9 by 2, which is 4.5. So we have W cube equal to 9 by 2 or 4.5. So therefore W equals cube root of 4.5. We have to take the cube root so that we get W. So this is coming as approximately 1.651. This is 1.651 is the W. So now let's check it up whether this point is the point of minimum. That is, at this value of W, the cost is minimum. For that, we have to find the second derivative and substitute this critical point. Basically, the value of W which we have found out is the critical point. At this point, either maximum or minimum value might occur. So we have to check that by either by continuing with first derivative sign chart or by using the second derivative test. So in second derivative, let's find the second derivative. Let me copy it over here. I have C prime of W, that is the first derivative of the cost function is 20W minus of 90 by W square. So I differentiate once again, that is C prime of W equals 20 times differentiation of W is 1 and then minus 90 times, this is differentiation of W power minus 2, which is equal to minus 2 W power minus 3 when you apply the power rule. So when I put this here, this is equal to minus 2 W by W cube. Let's get this simplified. This is equal to 20 plus 90 times 2 is 180 divided by W cube. Notice that this is going to give you a positive value irrespective of the value of the W. As already W is positive, if you plug this value of W into this second derivative, this is always going to be greater than 0, which means at this value of W, that is when W is approximately 1.651, at W approximately equivalent to 1.651, the cost is minimum. So to find the corresponding cost, all that we have to do is we have to plug this value of W into our cost function. So let's go back and take our cost function. So this is our cost function. So in this we have to plug the value of W equal to 1.651. So it is 10W square plus 90 by W. Our cost function is C of W equals 10W plus 90 by W square. So then we have to find C of 1.651. This is equal to 10 times of 1.651 plus 90 by 1.651 quantity square. And when we plug this into the calculator and approximate, we get the cost as $81.77. So this is the cost of the material required to construct the storage container, the least expensive storage container. So we have answered the question 3 as well. This is $81.77.